Welcome back, Calxers. It is my hope that your brains won't be too terribly wrinkled following this. So we'll get there. I want your brains wrinkly, just to be clear, because that makes you smarter, more surface area for more brain cells. We're not smooth brain, but we're not going to be crazy wrinkled either. And we'll get there. It's such a weird word. I kind of love it or hate it. I can't decide. All right. Anyway, this is the manufacturing costs. Now, if you wanted to figure out how much material was down here, what shape is it? And this is a circle as well, right? And the cost that we're given is in square units, like area of it. How do you find the area of one of these bases, or both of them? So it's two of them. And what's the area of a circle? So here's the area of the base, pi r squared, and there's two of them, and then it still costs 3/4 of a dollar. Everybody okay with what we've just done? This is just the area of the base times the cost, and there's two of them. Okay? Plus, and we're gonna switch to blue here in a second. Here's the harder part, and I was not your geometry teacher, so I'm not sure. When I unfold this, that blue one, is it a nice shape if I were to unfold it and put it together? It's a rectangle. Now here's the big part. So this is like the same thing. If this is my cylinder, if I want the area of this rectangle, it's length times height, or base times height, however you want to word it. But notice what happens. My length is the what of that circle. It's just the circumference of this circle. So here's my cylinder. If I unfold it, it's just this big rectangle where this was the circumference. And how do you find circumference? So 2 pi r. So what I have here is that the side of this thing has area that's length is 2 pi r, and we haven't even selected another variable yet. So we'll get the 1/2 there in a minute, but that's just the length. How tall is this? And what should we call this? That's a good choice. Now you can't see it, and I wish that I had kept it so you could. This is the other one that it should have on here. What's this measurement? That's my radius r. I got to do attendance because Angel's gone today, but we'll get there. So 2 pi r is the length, and the height Sean said is h. And then it's how much for each of these? 1/2. Now we are close to having a nice true primary. We're like, this is our primary function. This is the thing that we're trying to optimize. Should I clean it up a little bit, or should I just kick forward with where we're at? Let's clean it up. What happens on this one? So 3/4 changes to 1/2, or sorry, 2/4 changes to 1/2. And I'm going to write this ugly. I could say it's 3 pi r squared over 2. I could write it like that. Now, when I actually do this, because I know that we're going to be doing some calculus here in a second, I think it's easier, and I'm just going to switch to all black here because I'm not going to switch colors anymore. I think that 2 divides out. So I'm going to write this as 3 pi over 2. And what was the variable? Still stuck there? R squared. Why would I write it like this instead of the more maybe natural 3 pi r squared over 2? Why is this the better choice? It's my constant multiple. When I'm thinking ahead about doing the derivative, that's what this is going to let me do easily. How about the right side of this? Anything nice, or what nice thing happens here? 2 and 2, so it's just pi r h. Okay, why is this just my primary rather than my true primary? There's 2 variables. If only my manufacturing company was kind enough to have hooked me up with some additional information to create a secondary equation to eliminate one of those 2 variables. Well, hold on here. What's volume? It's 1,000 cubic centimeters. And how do you find the volume of a cylinder? It's not pi r h. Good. Sorry if I just misheard. And you said V is 1,000? If I write this equation, can I now take this primary equation and get rid of one of these variables? Which variable should we get rid of? Should we get rid of h, or should we get rid of these 2 r's? Let's get rid of the h. I would solve this for h so that we can plug something in for it. That's where I want you guys to kick back in. Doing this like doing it without any actual math, did this help make sense of what's going on? Some of you, yes. Some of you, maybe not. Hopefully it didn't hurt anybody. I want you guys to kick forward. I'm going to come around with my handy dandy note sheet, and all I need is some evidence that you have done the maximizing the area one. And we'll check the answers here in a minute. So you guys keep working on this for a minute. Hopefully that push in the right direction is helpful, and I'll come check out the other ones. So if you're backward, we'll figure it out. Little typos like that, they suck, but they happen. And they're on the same page, right? So I can just come around and look, and you don't even have to do anything. Love that you have exact stuff there. So this is box optimize. Oh, I'm still recording. I can pause it, I suppose. So anyway, my true thoughts about Angel are, what do you guys get for, we're just going to kick back in. Looking at this, here's our secondary. I'm going to trust that you guys can solve this one, but you're going to ask questions if you don't understand, right? I think that we get h is 1,000 over pi r squared. Like, there's nothing crazy that happens here. And now I'm going to take this value of h, and I'm going to plug it in where? Right here. These are going to switch places. Now, the whole point of that is I can now write my true primary. And instead of just writing c, what am I going to write? It's c of r. It's the only variable that I have in here anymore. So the cost with regard, or with respect rather, to the radius of our cylinder is exactly 3 pi halves r squared plus pi r, and we might do a little bit of simplifying here again, times 1,000 over pi r squared. Just a quick substitution, and now we only have things with r, which is a good thing for us to have if we're going to take the derivative, which is exactly what we're about to do. Anything nice that divides out first? The pi r, and the pi r leaves just a single r down here. So we'll go one step further, and just to write it nicely, as nice as I can, c of r apparently is 3 pi halves r squared plus 1,000 over r. Okay, now the domain thing is always odd because you can think about the domain now. I prefer to think about the domain once I actually find numbers to see if they make sense or not. But let's just think about a couple things. The radius has to be greater than what? Has to be greater than 0. So if we get a negative critical number, it's already out. Do you think there's an upper bound to the radius? The height has to be greater than 0, right? So there must be some value of the radius that would allow me to have a cylinder that's like this tall, which would be weird, but I could. Would that be a lot of area with the expensive top piece? But we're okay with this, I think. So I now have a wonderful function in terms of one variable. I know the radius has to be greater than 0. How do we start finding the maximum, or the minimum rather, of the cost, c? Let's find the derivative. Now, and I could just write c prime of r, and that's not incorrect. But if I want to show what I'm doing, this is d what? dr, nice. It's just telling us take the derivative with this as our variable. Okay, so we'll just go nicely. Does this derivative work out pretty conveniently? When I take out this constant multiple, it's just 3 pi halves. What's the derivative of r squared? 2r. So the 2r and the 2 just fall out. So it's just 3 pi r. That's easy. And this one, we're going to think out, do I quotient rule this? You can. I'm not going to. In my head, I'll rewrite it for us just in case, but what do I think of this in my head, and what do I hope you think of it in your head as? 1,000 times r to the negative 1. And the reason that I want you to think about that, and I will write it here, and I'm going to undo this here in a second. We're just going to do this. 1,000 r to the negative 1. Why is this a beneficial way to think about that? So Delilah, because you suggested, I think you know why. Why would I do this? Yeah. What happens to r to the negative 1? Where's the negative 1 go? So negative 1,000 r to the, what happens with the power? So now minus 1 more, it's negative 2. So I think it's just minus 1,000 over r squared is what that's going to be. Minus 1,000 over r squared. Cool. Here we are. I have a derivative, and it's not terrible. What do I do with this derivative? So I find the zeros. And what are they actually called? Like, you're right. The zeros of the derivative, the critical numbers. So here we go. I'm going to do some scratch work on the way down. I'm at the bottom of the page anyway. I would, do you want me to solve this like out loud? Could we just all solve it? How do you want me to go through this? I'll just talk through it, and you guys let me know if there's questions, because I don't think that this is a crazy hard thing. Okay, so first thing I would do is there's a 0 here. I'm going to add this to both sides, and I'll take little steps. So 1,000 over r squared equals 3 pi r. I'm going to multiply by r squared and divide by 3 pi. So we get 1,000 over 3 pi equals r cubed. And then I'm one step away. I can't scroll down anymore, unfortunately, but I think that this allows me to get my critical numbers. Now, check me out. I don't have a calculator handy, and I don't really care what this approximation is right now. What's r without calculator? So the cubed root of 1,000 over 3 pi. Now, we could simplify or change this a little bit, but we don't have to. 1,000 over 3 pi. I have no idea what this number is. 1,000 divided by 9, I don't know, it's around 100, right? A little bit smaller than, or a little bit bigger than 9. So it's around 100, whatever the cubed root of 100 is, 4 to 5, somewhere in that range. No idea, don't care. We have our critical number. Now, that's it. That is our critical number that we have to deal with. Is there another one that I'm ignoring right now? Anywhere where it's undefined? In this form, it's a little bit harder to see. In this form, it's much easier. What makes me undefined here? What value of r? 0. So I'm going to include it here, but I'm immediately going to say this. Why do I know that's garbage? Yeah. Try to build a cylinder whose radius is 0. It's a line. You doesn't. You can't. Okay. So that's that domain thing coming back in, like all of a sudden here. Okay. Number line? Or is there an easier way? Let's do the second derivative. So I have just this amount of space. I think I'm going to be okay. If this is c prime right here, let's take the derivative again with respect to r, and we're going to find c double prime of r. And it's this guy. And we'll just do it piece by piece. K rad, what is the derivative of 3 pi times r? Love it. 3 pi. Fantastic. Ferngully, random thing. There's a movie from the 90s about fairies that live in the Amazon that are fighting against deforestation, and it was a very politically motivated movie. It's a weird one. It's called Ferngully, and I wish that I'd committed to this like 4 years ago. But Fern, what's the derivative of this other part? And it's plus now because we had a minus. Okay, plus 2,000 over r cubed. Quick question for you and for everybody. No matter what I plug in for r, assuming that it exists and it's greater than 0, what is that always going to be? It's always positive. Now, I like the way that we were doing it yesterday, where instead of just saying this is always positive, therefore, I want to actually be very clear with what we're doing. If I wanted to actually use the second derivative to determine if this is a min or a max, I would calculate c prime of which value. So I did see somebody do this, and you're clearly like pointing towards something on the board, but just to make very clear, Do you guys see what I'm looking at right there? No is the, like, you can't tell, right? What do I plug in here, though? Like, don't point. I need words. Or, yeah, words, I guess. The critical number, and it's here. The cubed root of 1,000 over 3 pi. Cubed root of 1,000 over 3 pi. And it's gross, but I don't actually need the number. Because if I plug in a positive into this, the second derivative was what? No matter what r I plug in, it's positive. So what? Is this a minimum or a maximum? It implies a minimum. That is the weirdest word. I hate it. Okay, minimum happens here. What were we trying to minimize? Okay, so we just did that. We just minimized the cost. What did the question actually ask? The dimensions. If I wanted you to build a cylinder, what's the required information you need for the dimensions? Not rhetorical. Talk with your neighbors. I'm going to ask the same thing. What do I need to give you? If I want a specific sized cylinder, what information do you need from me? Just those, right? It's just the radius and the height. If you give me those two and it's a right cylinder, we're all going to make the same cylinder. The cost is minimized. And we're going to do some scratch. It's actually not going to be that terrible. When, and I should say the cost of the cylinder is what I should do. The cost of the cylinder, and I hate it, but if I'm going to make you guys do it, I'll do it. When, and here we go. The radius, what did we find it to be? The cubed root of 1,000 over 3 pi. And then I just need you guys' help because I don't remember. What's the unit on these? Centimeters? And the height, and this is where the calculator list problem is awesome. It's 1,000 over pi r squared, right? So here's the cool part. We could get this actual value with a calculator, and if we were going to do it, we would need to. But this is a reasonable calculator-free problem. So I could just say the height is simply going to be 1,000 divided by, and we already said it was pi r squared, where what's r? It's 1,000 over 3 pi, the cubed root of it. So I'm just going to change the way I write this, 1,000 over 3 pi. And the cubed root is to the power of 1/3, but I squared it, so it's to the 2/3. Here is our exact answer. This is the cylinder that maximizes the area, or sorry, that minimizes the cost. This is ugly, but I would prefer this than using the calculator and having to get the ugly decimals. Unless I'm actually going to cut it, this is the answer that we should go with. Okay, where were you guys getting hung up, or once we did the setup, was it not terrible? That's a terrible way to ask that question because people go, oh yeah, and now I don't know which way. How did it go for you, Riley? So getting to here's the hard part for you? Okay. The calculus part of it, reasonable? Okay. So working on the true primary is what I would agree is the hardest thing and is what's going to get to be the hardest thing. These problems feel very similar to related rate stuff. They're certainly using the same ideas. We're going to have to go back and do related rates again, naturally. It's been a month and a half. So they're coming back. But cool. All right, let's check the box problem. Do we need to work through it, or can I just show you mine? What's the critical number that you find that works? 2.11? Love it. And that's what I was saying, Kalisha, you had that number. I'm going to jump in, and I'm going to show you where you just didn't finish. Okay. So if you want me to talk about this further, just let me know. But here we are. I assume that you have this box drawn. Probably. Now, it's easy to get goofed up and use x and y instead, but remember, just always read it really carefully. If they give you a length, put that length there. Let's make sure we don't make it more convoluted than it has to be. So our volume is 20 minus 2x and 10 minus 2x and x. The cool thing about this first step at our primary is it's already only has x's in it, which is super convenient. You could differentiate here and use an awful product or FOIL it out. I suggest you FOIL it and you wind up here. Okay, if you actually want to fold it up, what does x have to be greater than? So you have to actually cut something out, right? So what I can see, and the reason I'm commenting on that is if I were to take the derivative, and I do, here it is, it's possible that 0 could be a critical number. If it does wind up being it, we ignore it. Same with a negative, because you can't have a negative square cut out of it. But here we are. I used the quadratic formula and then my calculator, and I got two numbers, 7.89 and 2.11. Why is this physically impossible? Yeah, if you try to cut a 7 and 7 off of a length of 10, you need a 14-inch length. Like, it just doesn't work. You cannot make that happen. So it means my only critical number that matters is 2.11. Cool. Once we do that, you could use your number line stuff, or we can second derivative. And I think I had to grab the calculator to check this because it's not immediately clear to me if this is less than 0 or greater than 0. But I did show eventually with the calculator, I think, that it was less than 0, which means it was a maximum, which is what we're trying to do. And then we just need to plug it in. I think it should be 15.56. I'll give or take, and we'll talk about rounding stuff as we get closer to the test. 5.56 and 2.11. Cool. These feel easier. They starting to feel easier. Are they feeling just as hard? Okay. So the good news is that this is day 3 now. It's supposed to take 5 days. I don't think it's going to take all 5, but we'll see. I have it planned for it just in case. Let's do another one and see if we can't do a little bit harder. Okay. We are going to look at another cylinder problem. And here's our choice. Are we doing the cylinder problem together? Or do you guys want to work on it for a few minutes and we'll just check to see if it's going well? I like the second version, but I'm flexible. How about you read through it, and then as a class, once we get a couple groups saying, I don't know what to do and I keep getting the same questions, then we'll jump in and talk about it together. Or I'll find the people who don't have questions and you're going to be me. Not literally. I mean, you wish you were, but figuratively, you'll be me. Real quickly, do you want a quick brain break before we do it? Okay, so I give you guys brain breaks. Not all your teachers do, I don't think. Do any of your other teachers give you like formal structured brain? Like ours is always kind of structured. What other teacher does it? Eustace does it? Not everybody else does though, right? Okay, so first question, why do I give you brain breaks? Talk it out for 30 seconds. I'm gonna go get a drink of water. Why do I give you brain breaks? And I'm gonna pause it again so that Angel doesn't have to listen to this. Check this out. We're in the middle of the video real quick, and I'll give you your 30 seconds back. But Angel, my favorite number is 7 and 21, but 7's my preferred, and my favorite color is green. If you reference this upon return, I'll hook you up with some candy when it arrives. If you don't reference this, everybody else in class gets candy. There's only one rule. You cannot text Angel and say, hey, Angel, there's no video today. Like, don't burn her academic stuff for a piece of candy. But this is a quick check. Cool. All right. Why do I give you brain breaks? We are going to be looking at how does one maximize a volume of a right cylinder. So this is on the 3rd page. And just to be very clear, I don't want you to see my answer, but it's this one. Consider all the right cylinders for which the sum of the height and the circumference is 50 inches. Blah. I want to know the radius of the right cylinder that maximizes my volume. Cool. So this is on the next page on your sheets. I'm going to give you guys a few minutes to get started, and then I'll start working it. A right cylinder just means that it's a regular cylinder that straight down 90 degrees because we don't deal with them very often. But if you take a cylinder and slant it, it's still a cylinder, but now it's a harder to deal with cylinder. We just have a perfect right angle, perfect cylinder, just like the one we drew on the last one. Cool. I'm going to give you guys a couple minutes. So I'm going to continue up here a little bit. I have the primary, the secondary, and the true primary. And then I split these a little bit. I'm going to do my v prime over here, not capital R. And this looks, do we need to talk through this derivative or no? Okay. It looks like it's going to be awful. Just remember that's a constant. So 50 pi times 2r is 100 pi r. This 2 pi squared is a constant. With this is a 3r squared. So it looks like it's going to be minus 6 pi squared r squared. Okay. These are just constants. Did I lose somebody here? Kalisha, I heard wait, what? Can you expand on that a little? I assume I lost you here a little. Check it out. If I just put parentheses around this, and what did you say the derivative of r cubed was? So here's my 3, and it's r squared, right? 6 pi squared. I split it because I'm just moving the multiplication so it looks nicer. Okay, from this, here's where we're at right now. There's one more problem on that page and one on the back, right? Okay, I want you to finish this problem. If you want to check your answer, I can tell you what the answer is going to be if you want to check it. It's 50 pi over 3, right? 50 over 3 pi. This is where you're working to 50 over 3 pi. Just like yesterday. Tonight, I want you to do... Ooh. I want you to try it. Give me like 15 minutes of solid try something. We did not do a problem like the next one. You have the skills to do it, but it's different. Cool. Minimizing a distance is your homework tonight. Finish the problem that we just did. Get to 50 over 3 pi, I hope. And then minimize the distance on the one below. And we'll look at that one tomorrow. You guys have a slap happy day. Travelers.